Hello, my calculus kids. This is the very last section that we need to cover before the exam. So section 10.4 is the last new material that you will have to learn. And it's a little bit interesting. It's called separate the variables, separation of variables sometimes. You got to separate them. You got to keep them separated. X is on one side, Y is on the other. And so that's really the big kind of thing with this. And what they're asking you to do is they're giving you the derivative. They're giving you the slope, and they want you to figure out what was the actual equation that came from. So you're kind of working your way backwards, which means we're going to have to integrate. So the story is you've got to have the variables, the x's on one side and the y's on the other. And so what you do is kind of a cross-multiplying deal with this. I'll show you in this first example. So if I were to cross-multiply this, it would be, well, let me do the y's. It would be y times dy equals 3 cosine of x dx. You got to put it with the dy's and dx's at the end, just like we always do with these. And once you have the variables separated, then you need to integrate. And you're going to integrate this side with respect to y and this side with respect to x. And so if I were to look at this, if I integrate a y, I get a y squared. And if I integrate an x, over here, the 3 stays a 3, it's just a constant. The integral of cosine is sine. I have just an x, so it'll be divided by 1, but I don't have to put that. And then there's got to be a plus c somewhere because I don't have any bounds. They didn't give me any kind of information, so I've got to have a plus c with this. And the story is, what is the original equation? Well, equations are normally solved for y, and that's what you're going to do with this too. If I solve this for y, that means I need to take the square root. So if I square root this side and I square root this side, I end up with y equals plus or minus the square root of 3 sine of x plus c. And the plus c is still inside of your square root there, since you square rooted both sides. Now, if they gave you some more information, you would be able to determine whether you're using really the positive part of this or the negative part of it, but they didn't, and you'll see that come up in another example actually over here with example number 4, where they gave you some more information. You can determine whether it's really just the positive part of this or the negative part of this. But for now, you don't have any further information, and so that's your final best answer. So there's number 1. Now sometimes you have to do a little bit more manipulating in order to put these things, set up the fractions before you integrate. So if I do the same trick over here, I'm not a fan of this 1/3. 1/3 is, if I multiply both sides by 3, I can get rid of that 1/3. That's going to give me a 3 dy over dx equals y plus 2. Now that looks a little bit better to me because I don't like fractions, so I'm trying to avoid them. And what I want to do is the same type of thing. I want to get the x's on one side and the y's on the other, and I can see that the right hand side has y's. So I need to get this dy over here, which means I would have to divide by it, because see how it's on top? So if I want to get it out of there, I'm going to have to multiply this side by 1 over dy and this side by 1 over dy. So that's going to give me, my dy's cancel, that's going to give me 3 over dx equals y plus 2 over dy. Which makes me somewhat happy because if I look at this, that means I've got the x's on one side and the y's on the other, but the dy's and dx's are in the denominator, and that's kind of upsetting. So I need to get them into the numerator. And here's some rules with fractions, back to proportions. You can flip these. As long as you flip both sides, the math police won't come and take you away. An equivalent form of this proportion would be if I took and flipped it and made it dx over 3 equals dy over y plus 2. So that now I have my dx's and dy's up in the numerator, which is awesome, because really what this means is I have a 1/3 dx, and I have a 1 over y plus 2 dy. And the reason I'm playing games with this is because I know I'm ultimately going to have to integrate it, and I want to get it into a form that will be happier to integrate. All right, so I'm going to now, I've got it set up. I'm going to take the integral of this side with respect to x, the integral of this side with respect to y. And you'll notice in this particular one, my x's are on the left, my y's are on the right. Where in the last one, my y's were on the left, the x's were on the right. That's okay. Just you're separating them, one on one side, one on the other. All right, let me try to integrate this thing. So if I have a 1/3, that means I really have a 1/3 x. I'm going to leave a little space, and I'll tell you why in a second. This one is a 1 over y plus 2, and anything that's 1 over something is going to be your ln's, right? So I'm going to have the ln of y plus 2. All right, that's what this side's going to be. Somebody's got to have the plus c, right? Either the left or the right has to have a plus c. Somewhere there's got to be a plus c in there. And you can see that over here, because there's an ln involved, it would be much easier for me to put the plus c on this side so that it doesn't get all hung up in this ln. So either the left or the right has to have a plus c. In this case, it was easier to put it on the left with the x. All right, so here's where we go next. This whole thing's all one piece there. I'm trying to get this solved for an equation that's in the terms of y equals. Well, I can't undo this from the ln. The y is all tied up with the ln. The only way that I can undo that is go back to, I know you're going to love this, our rules for exponents and logarithms. So remember, there's an invisible base of e that's here. And if I do my loop on this, remember loops from back in pre-calc, it's going to look like this. E to the 1/3 x plus c equals y plus 2. And you can see how you got that out of there, and it's going to be somewhat easy for you to be able to solve for y because you're just going to subtract the 2 over. But before you do that, we need to go back and remember some rules for exponents. All right, here's what this means. This right here would be the same thing as if I had e to the 1/3 x. If it's a plus, remember with exponents, like say I had x squared times x cubed, I would add the exponent to be x to the 5th. So same idea with this. If I'm adding the exponents, it's really the same thing as me multiplying those two things. Equals y plus 2. I'll change the color just so you could kind of get the gist here. Well, think about this for a second. E to the c, e to some constant, e to the 1st, e to the 10th, e to the 243rd, whatever it might be, is still a constant. So this whole term here becomes a constant times e to the 1/3 x equals y plus 2. And then you can solve it out. Your final answer for this guy is y equals, right, the equation, and it's going to be ce to the 1/3 x minus 2. And that is bringing back some of your exponent and logarithm things that kind of they do come into play with these separation of variables pretty often. Okay, so here's the next kind. The next kind say, okay, well, do the same thing you did up here, but I'm going to give you some more information, and that more information is going to enable you to be able to figure out what the actual c value is. So you're going to have the actual equation for this because they gave you a particular coordinate. All right, so if I do the same thing, get the x's, the same thing I did up above, I'm going to get the x's on one side and the y's on the other, so it's kind of like a cross-multiplying little tricky poo here that we do. If I take the y and want to move it over here, I have to divide by y. That's going to make this dy over y. This has the 3x squared, and the dx, I'm going to multiply both sides by dx to get that up there. So this side I had to multiply by dx, this one I had to divide. All right, so if I take now and set it up so I can integrate it, I don't like the dy and y together. I like them as separate pieces. So it's going to be the same thing as 1 over y dy equals a 3x squared dx. All right, and if that's the case, now I'm ready to set it up so that I can take the integral, and I'm going to integrate this side, and I'm going to integrate this side, the left with respect to y, the right with respect to x. And so if I look at this, 1 over y, we know what that is. A 1 over something is an ln. So this one's the ln of y, and then equals. This side would be a 3x add a power on, divide by the power, and then a plus c. And again, I didn't put the c over here because it's got ln's involved and it just gets more complicated. All right, these cancel. So here's where I'm at now. ln of y equals x cubed plus c. Now, you can go ahead and solve it for y and then find c, but that tends to be more difficult than if you just stop right here and figure out what the c value is. So that's what I'm going to do. I know that y equals 1, x equals 2. So ln of 1 equals 2, not 3, 2 cubed plus c. Well, what to any power is 1? And that would be 0. So the ln of 1, and you can check it in your calculator, but the ln of 1 is 0. 2 cubed is 8. And so I can tell that my c is equal to a negative 8. And so I'm going to go back to this equation right here, and I'm going to put in the fact that I know that c is a negative 8, and see if I can solve this for y. So here's where I'm at. ln of y equals x cubed minus 8. And your job now is to solve that for y. So guess what? Y is attached to the ln. I got to undo that, and the only way to undo that is with our exponent rules with an e. So if I take this thing, there's an invisible e here. I do my loop-de-loop. It's going to be e to the x cubed minus 8 equals y. And that's my answer right there. I've got my y equation. I could use rules for exponents and separate this and put this as an e to the 8th. Remember, minus means I'd be dividing by it. So you could, if you had a multiple choice question, it might be finagled a little bit differently, but this is a perfectly valid equation for what this one is. All right, here comes the last one that's of any difficulty because number 5 below is easy peasy. So same thing, get the x's on one side, the y's on the other. This one is just going to be a straight cross multiplying, which is cool. So I get e to the x dx equals 2y dy. And see how that's set up perfectly for you to be able to just integrate it right there. So here I go, integrating. The integral of e to the x is e to the x. The integral of a 2y is a 2y add a power on, divide by the power. And then somebody needs a plus c. Let's put it over here with the x. Cancel over here. So here's where I'm at now. I've got y squared equals e to the x plus c. And again, at this point, I want to substitute in and see if I can figure out what this c is before I solve for y. So I know that y is negative 2 squared equals e to the 0, x is 0, plus c. Negative 2 squared is 4. E to the 0 is 1. Don't forget that's not 0, it's really 1. Plus c, if I take 1 away, now my c is 3. And so here's my equation at this point. Y squared equals e to the x plus 3. And so when I go through and I square root this, just like I did back with number 1, I get y equals plus or minus the square root of e to the x plus 3. Now, if you remember, I said that it's going to be plus or minus unless they give you an initial condition. And because of this condition, I know that my y value is negative. The only way this can be negative is this square root is negative. Because if it's a positive square root, then y would be positive. So the only way I can come out with a negative 2 in this problem, because they gave me some extra special information, is if it's just the negative one. So because of that, because y equals negative 2, it can only be the equation y equals the negative square root of e to the x plus 3. Okay? If they hadn't given you that initial condition, then you leave it as a plus or minus. So there's a difference between those two things. All right, last one. Here goes. Number 5, slope fields. We love them, little slope fields. This is the slope field for this guy over here, number 4. Draw a particular solution for what the function would be when you get the coordinate f of 0 is negative 2. In other words, you're looking at the coordinate where x is 0 and y is negative 2. So you go to your pretty little graph, and you go and you put a little coordinate at negative 2, 0, negative 2. And then all you need to do is graph this thing staying between the slope fields. So like the cattle chute kind of thing I talked about before. Here it goes. I'm staying between I'm staying between and not crossing over. You're looking for an approximate graph. That's what it would look like right there. Okay, so that is your introduction to section 10.4, and I will talk to you again soon. Hope you're all doing well. Bye.